So now we turn to the main example. So after having looked at the basic plotting and the scraping of the data. So here, if you remember, this was the main from the scraping of the data from all the nations based on the function in this simple module. So what we're going to do is extending this code to actually do the plotting that needs to be done. So here, the beginning is similar. There are a few more utility functions loading the Bokeh, the component of the Bokeh library, and just a single function of the SciPy library. And again, as we did before, we kind of have a simple loop. So this is the same as before. We look at a loop over the nation that we have chosen kind of manually here. As I said, Italy, USA, and Brazil. And those are some of the nations that I've been looking at, being Italian, living in the US, and having several friends that live in Brazil. And trying to make plots that compare the evolution of the COVID cases in those different nations. So here, once we load the data sets, and then we have lists with the actual plots, let me show how the data will look like, and therefore explain why we need to kind of smooth the data. So as you may know, the data has a lot of noise because of the practical reporting challenges. Kind of an obvious one is because, for example, during weekends, people don't report data, and then right after the weekend, there is numerical, you see a spike, but obviously COVID does not take a time off during the weekend, but the people reporting take time off. So here you can see that the data is kind of very jaggedy. Those are the weekly patterns. And obviously we're not interested in showing those, that just showing bias in the way the data is collected. Still, you can start seeing some of the trends. And so here, to do the plotting, and then I'll show the plot function, probably we need to kind of first smooth the data a little bit. And so here, we want to look at the data from the various nations, in this case, the 3 nations, and and read the data collected raw from the website, and then smooth it so that we can eliminate the bias at the high frequency level. So here we're looking at kind of 2 ways of smoothing the data. So first of all, we loop through the nations. So we have to do the smoothing 3 times, 1 for Italy, 1 for the USA, 1 from Brazil. I'm writing this as a loop so that this code can be easily generalized, and also so that the code inside does not get written 3 times. Later on, I'll show very quickly a piece of code where having written the code this way helps, because then I can collect the data for all the nations and then play through those very quickly. So we go through all the nations, and then I use this function signal that does from the signal processing in the module, signal that does signal processing in SciPy. And then here we're looking at this filter that smooths the data, has a couple of parameters. So this is the actual data, and it has the window of the smoothing and the polynomial used in that. And so here, this loop is to do the smoothing a few times. So here is smoothing cycle, so how many times you do the smoothing. So you can have a low degree done several times, or a high degree done fewer times. And again, this is just to give flexibility one could adjust one parameter or the other, that would be fine. After the smoothing is done, then we assign that to this array data nation smooth, so that the data is ready for being plotted. So here, for example, if I do the smoothing only once, 0, and basically we saw the raw data, and we apply the filter with a window of 15, so it's a couple of weeks, polynomial or third order. And so here we can see the data that can get a little bit smoother. So it's not nearly as jaggedy as before. It's still retaining those kind of patterns that we probably want to eliminate. And so let's, so here you see that we can simply add more smoothing cycles, and we'll get to see the data smoother and smoother until we're satisfied with the level of smoothing. So here is getting nicer. At this point, it may be somewhat subjective. I would do one more cycle of smoothing, so I just go through the data 3 times. And here the data is clearly smooth. Just out of curiosity, if I I don't know, smooth it 10 times, well, let's see if I'm going too far. It's definitely going to be, the code will be much slower, obviously. So here the data is really, really smooth. At that point, if we do it too much, we run the risk of losing the actual structure of the data, right? This can be just a very basic blob. But anyway, as usual, also when you look at a plot, you should ask yourself how the data was manipulated. Very, very rarely you just see in a plot the raw data itself. Very often the data needs some level of adjustment. Notice that the smoothing inside the loop is just a single function call, but I could have used, for example, like a wider filter for example. So you see kind of the difference in results. Sometimes the difference is significant, sometimes it's not. So here, much smaller filter, degree, just 1, and run the code again. So, and in general, it might be good for you to kind of, you see, now it's still very, very jaggedy. Having the window so tight tend to make the data. So instead here I can make the window much larger, and this is the type of result one would get. Of course, always you see it's still kind of a little bit jaggedy, but it's fairly smooth for doing a single pass. So for example, doing a larger window, even if it's low degree, probably 2 passes might be good enough. Yeah, you see 2 passes. In fact, it's even overly smooth, right? So here we lost some of the features in the data. So at the end, you kind of have to figure out what is the right level of smoothing that you want to have. And you have to understand a little bit the data to make that kind of judgment call. And hopefully you see now this is clearly a feature of the data. It goes through a long enough period of time. What I showed before was overly smooth, right? So you have to do some based on some your knowledge and information. The important thing is that in terms of code, you know how to tune those things, and then as an engineer, we'll figure out what is best. Now we go to the actual plotting code. Again, very simple as usual. We create a figure and say comparison of the death rates. I think this is not needed. So here, well, we'll put labels kind of rotated a little bit. Those are all the dates. And then here we have, we look through the nations. And so the X is just a list of categories, the list of dates collected. and the y is the value for each of those, right? And so here you see is exactly the same code that we saw before. I do a line x, y with some legend, and then here I have an area with a very high level of transparency. I add the zeros to do the shading from the x-axis, and then value y for that. And so I can run this. I guess you already saw, but now you see the code the way it is. So now here you notice that the labels here are sideways. So given that those are dates are very long, if I were to, let's see, remove the angle for this, those would be horizontal, and I think it would be harder to read. But anyway, let's look at, you see that they're one after the other. It gets harder to understand which of the tick marks is associated with each label, even if they don't overlap. And so it's often customary to put an angle. I mean, I could do it vertically, but then they become hard to read. But generally here you have an angle, see, like this, a little bit harder to read, or still they're okay, and they take a little bit more space. So one approach. But anyway, so here you can literally put any angle you like. So, and you have to just put the angle in radians. That might be not very intuitive. So 314 would be 180 degree. So 90 degrees, half of that, to 45 degree would be divided by 4. So normally the x-axis is given a set of actual just numbers, 1, 2, 3, 4, and so on. So let me comment away this part. And so instead of the dates, you will see there is just the day from the initial sampling. So this is not very informative. So with this little loop, one can give a dictionary here, right? So that you have the category and create the mapping between the categories and the string with the date. So with this one, we replace the numbers from 1 to 600 plus. So those are almost 2 years worth of data. And so, but in this way, we can see when they are. So started in February 2020, all the way to, well, if it were to go longer, so it's here, it's early December, we'll keep going as. And it's interesting, since we're scraping the web, anytime we run this, this gets slightly longer, I mean, day by day, because data gets updated, and so you get a new plot every time. So this should be fairly easy to understand, given the data, how is it collected, and the information plotted in this very simple way. Now, let's say that we want to do something a little bit more interesting and do 2 plots, one with the daily death rates and but also the cumulative one, to see basically still proportionally, but which nation was struck the most. So here on the second option, I'm adding a second way of dealing. So here's the collection and smoothing of the data that we just saw. The first plot, so up to here, the information is the same, and this is the first plot. So here then we can do some very simple calculation to go from the raw data to the cumulative information. So here we have an array, sorry, a list, so of one list per nation. And so we collect the data for each of those. Cumulative data initially, it's an empty list. Let me highlight this way. So here the cumulative data initially is kind of an empty list. Here we can use a partial sum that we initially set to 0. And then we have a loop here kind of this loop up to this line, where we read one element at a time of the data from the data of each nation. So looping through the data of each of those nations, one datum at a time. And the partial sum, it just is incremented by that. And the cumulative data then is another list where at the end we add the cumulative value and not just the individual value. So this is kind of a simple way to go from the daily data to the cumulative one that is stored in this array. So nothing particularly fancy. So let me go back. So now we just have to plot, to create a second plot. Again, this plot is nearly identical, except that the values are different. So we make a different label. Same thing, put an orientation to x-axis, label the x-axis. And now we do the line and the v-area. So effectively, those could be wrapped into a share function, but it was done only twice. And now in the show, the only somewhat interesting addition is that in the show function, you can use this method called row, where you can take two plots and show them side by side in a row. So let's look at the result of this. Let's look at the result. Let's launch the code. And now you will see the two plots side by side, same x-axis. The y-axis are different, again, because this is the original data. And here it's a monotonic because we're adding one day at a time. So you notice that when this goes up very quickly is when this plot has a spike. Then the plot goes down. Here it's almost flat. There is a second spike. Here in Italy, another ramping up. The slope changes a little bit because of those two spikes. And then at the end, it's kind of keep growing, but at a very slow pace. What's interesting is that, so here Brazil has two spikes, but the first one is actually not as high, but wider. So here you see this kind of longer ramp, but the slope is not as high as this one. And so here you see the slope correspond to this particular spike. And then there is this huge spike, is the largest among all, both in terms of width and height. And in fact, that corresponds to this growth in fact normalized to the population. Brazil now has a greater number of deaths, right? Here you have maybe 2,800 or 2,900 people that died per million throughout the entire pandemic. So if we look at the USA, let me clean up here. This is the green plot. So USA, instead of two, had three spikes, maybe none of them as high. So you see there is this one, and this one. And so you see the plot, initial spike, they got the pandemic a little bit later than Italy. So I think they were a little bit more prepared. So the first spike was smaller. First time things ramp up a lot. It never went very low. This actually, you can see the difference in strategies. Italy has a huge spike, probably total lockdown. So the US kind of never fully closed. So they had the low end was not very low. So you see, in fact, keeps growing, a second spike, then the ramping up keep growing. It becomes flat a little bit here, this low here, another spike, and things can going up, and then is ramping up, not as high. So here it's interesting how you have this crossing over among the different countries in terms of the total mortality due to the pandemic. And but this has changed many times, so it's hard to predict in the future. At the moment, I mean, they all had very high impact. Brazil a little bit greater, medium, kind of the US, and Italy, which initially was much worse, now seems to be doing better. But again, those things can kind of change entirely over time. But the point is that as an engineer, we can make nice plots that help comparing things in a fairly neutral way, and then make our own conclusion in terms of, for example, what approaches would work and things like that, and generally how to present the data to other collaborators or to the public. And this concludes this part of the course. So ideally, we would like to get to the point where you can create a plot like this overall. I'll make another brief video of how to make this plot actually animated, but again, I don't have expectation that people need to for the class itself to build a code like that. But I think it's a good thing to be exposed to that as well. I'll also share actually I might show it now, a MATLAB version of these plots, just to show they're very similar. Again, this officially we don't need to learn the code, but I'll show just quickly how that would work. Set this one as a startup file. So here the code is, if you can see, it's kind of very similar. Categories, the setting up of the figure is a little bit more laborious. You will be able to look that into the code. Here you have a show function also, but it's part of the plot itself instead of a separate method. And so let me run this code just to give a sense that you can make fairly similar plots with different libraries. The difference is that this is an image here within the Python environment, while the other one was an HTML file. So this one, maybe you can take a snapshot or something, but you cannot easily publish it as an HTML, a vector, basically HTML on the web. Here you see the dates. Yeah, the only thing that I did is slightly different, that I did one plot at a time. So I can add the second plot. Let me see, maybe there is a problem here. Let me try again. So here, first plot. So here we add Italy. Again, this is a little bit easier. I made them a little bit wider. So you see the difference in the first spike in Italy. The pandemic started earlier than most places. And it has like those two big humps. One kind of almost divided by two, and now it's fairly low. Brazil had the first one much later and not as high, but then really much bigger later on. And then the US with this different pattern with a somewhat high hump. It never got super low at the beginning. A second wave and a third wave recently, while the other countries had a different pattern. And here, if we look at the cumulative numbers, you see Italy that had this initial, see the structure of the ramping up as we discussed before. And something problematic is going on. I'll just run it quickly. So this 1 second, third. So USA, so you see how they cross over each other several times, kind of initially it is higher, then US higher, Italy is higher again. And so 3 times Italy was higher, and one a little bit, 2nd time, 3 times they use US higher, so maybe it's reasonable to expect that will happen again. And similarly, Brazil initially was almost consistently below, then after the last big wave, they are consistently higher. So anyway, with different tools, one can build different plots very effectively. And depending on what you need to do, one can use one tool or the other. I kind of recommend Bokeh as a good modern solution. Obviously, Matplotlib is really great, and for many engineering use cases, that's a great choice. Very high quality picture for publications. As soon as you want to do something web-based, unfortunately, Matplotlib has an old design, and it doesn't work well that way. There is also a way to combine the use of the two. If you really like Matplotlib, there are ways to combine it inside Bokeh or other environment. I don't know that I would recommend that option just because it's so let me see here. You see how we open the example. Again, those are reduced as an HTML file. But again, I don't know if I recommend to mix too many libraries together. It can make things complicated. And if you invest the time to learn one, you might do everything, if possible, within the same line. And so we'll do in the material regarding Bokeh, static is going to be included in the final. But the next topic where we talk about making things animated, it's just an extra topic, is not required for the class. Thank you.